Let's go through a couple things here. Yes, it did.
Hey, haircut.
Yep. Got a lot of them. All right. Now, let's go through a couple examples here. Here's the goal today. I want to do a tangent problem where we shift it right, left, up, and down. We only did kind of an intro problem yesterday. I'm going to stick with kind of an easy one to start with, or Friday. And then we're going to do a cotangent problem. And then after that, I'll probably do one problem of like secant or cosecant. We haven't seen one of those yet. So expect about 4 to 5 problems today in your notes. 4 to 5 problems in the notes, and then we'll be done for the day. I'm going to try to go as fast as I can. So some of those days where you're like, wow, why are you going to rapid speed? I'm going to try that today. I want to get 5 problems. That's a tall order for the stuff we're doing right now. Okay, so for the first one, let's start with something easy for tangent, what I consider simple. Let's go with like 3 tangent 4x plus 1. I'm just going to do the simple stuff right now, the up, down, the period, and the amplitude. I'm not going to do the right and left shifting yet. That'll be something a little bit different. Okay? Expect a new assignment tomorrow. We have an assignment due tomorrow. That's your worksheet 1.5 part 2. A lot of you have already got that finished, done, complete. It was on cosine. So if you need to go back and finish that up, you can do that. I know a lot of you already turned those in last week. Just make sure you turn in the sign that was due Friday and then cosine's due tomorrow. I want to try to go through these fast as I can to give you a little bit of work time at the very end, and I'm going to go quick. I'm not going to waste a lot of time. So if you get lost easily, you better ask questions very, very quickly. All right, so 3 tangent 4x plus 1. Now, tangent is centered over the origin. It's centered typically over the origin. We are going to be shifting mine up 1 spot. We're shifting it up 1. So this is the new origin. It's going to go right through this origin. It's going to have 2 markers going this way and 2 markers going this way. Now I'm comparing it to, I'm comparing this, I better put a 1 like that. I'm comparing this to where it would normally hit on the x-axis. You do not have to have the x-axis in there if you don't want to. I'm just putting that there to show you what's really happening here. If you want to just put yours like this and get rid of that line and just say the middle is the number 1, I'm totally fine with you doing that. And just putting 2 hash marks to the right, 2 hash marks to the left. The amplitude goes up 3 and down 3.
So is anybody zooming in this class?
It should be Trav. If he's feeling up to it, I doubt it. If he's homesick, he probably doesn't feel very well. So. All right. Okay, the 4 hash marks. Typically, the full distance across is pi. Now, this is for tangent, cotangent. They're unique, right? The normal distance all the way across is pi. But in our case, I have to divide by 4. So I'm going to have to divide this by 4. So the entire distance across is pi over 4. That's just what we do, right? That's how you do it for sine. That's how you do it for cosine. Whatever the full period length is, you divide by the number in front of x. So I have to split half of that over
So
here.
you do the full period length, not just the half side period length.
What?
I had a little mini stroke in the middle.
All right. Hey, we'll let you just.
Instead of 2 pi.
Okay, yeah. Pi.
I meant
Okay.
I don't know.
on the right side of the vertical line.
Okay, right side. We're gonna do half of this still.
We're still doing half.
We're still doing half.
Oh.
So the full distance is pi over 4. So half of that is pi over
I don't know
8.
what happened.
Okay, and the other side is negative pi over 8 because I'm doing half and half. That's half of pi over 4, right? Half's on the right, half's on the left. And we still have to cut that in half again, so this is pi over 16 and negative pi over 16. Okay, if that's what you meant. Now, bless you. Going up 3, I'm going to hit the number 4. Going down 3, I'm going to hit the number negative 2.
Don't forget the asymptotes.
Okay, yes. And now, if you didn't hear, okay, Heitland said it. The outsides, you need to have the asymptotes. The outside markers.
Dotted lines, right?
Yep, they're just dash lines. Okay. All right, asymptotes, they're on the outside. Now, tangent starts in the upper right corner. It's going to hit the first marker at its amplitude. It'll go through the origin. It'll hit its next marker at the amplitude and then go off to negative infinity. This is a normal tangent. And it just kind of curves into it. It's not really a line. It'll curve When it gets there, it's kind of a smooth curve. Sorry, it looks terrible the way I'm drawing it.
That's pretty decent, actually.
All right. Questions with that example? I consider that an easy tangent problem.
It's
You have
positive,
amplitudes.
so it goes like this.
Yes. If it was negative, the only difference would be the whole
Negative
red
slope.
graph would just be flipped over, so it would go this direction.
So it's like positive slope, negative slope.
Yeah, exactly. Good way to think of it. Positive slope, negative slope.
Next,
Okay, next, let's do a difficult problem
a tangent.
of tangent.
Mr. Ward,
What?
could there be a tangent graph?
I just
that's
requires
no
the
asymptotes?
ever limit.
That's all asymptotes?
That's none.
No. They have to have them on the outside. Because that's where it would be dividing by 0 at some point.
Because if you didn't have them, would it just be a whole bunch of little squiggly lines?
Yeah, if you graph on a calculator, they would just show you all the tangents, and sometimes like my graphing calculator doesn't show me the asymptotes between. Sometimes it does, you can turn the feature on and off on the calculator. So you can just see a bunch of them side by side by side by side, and they all just look like they're parallel to each other. So, yep, because it would just repeat over here and do the next 5 hash marks and keep going. Okay, all right, next example. Okay, now we're gonna switch up the difficulty a little bit. Let's go with 1/2 tangent 2x plus pi minus 3, let's go minus 3. Just kind of make up something. Okay, so now we've entered the difficult town. We are shifting it right and left, up and down, all that good stuff. We are going to do the exact same procedure that I did on sine and cosine. I need to figure out what the spacing is. Then once I have the spacing down, I have to figure out how far right and left to shift it. And then once I have that, then I'll worry about amplitude and my origin line. Okay? So, now spacing. Normally, so on a normal tangent graph, the normal like frequency is pi, right? That's the normal period length. I have to divide by the number in front of x. So that I have to divide by 2 in my case. Because this is the number I'm dividing by. So that means half of it's over here, half of it's over here. So half of pi over 2 would be pi over 4 and pi over 8. Why I brought this up? Pi over 8 is the spacing. That's your spacing number. Because the whole distance is pi, I divided by the number in front of x to figure out the whole spacing. And then I had to cut it in half to figure out the actual individual hash marks. This hash mark is what I needed. What is the distance to the first marker? It's pi over 8. Okay? So now that I know this spacing, now what I got to figure out is how far right and left am I shifting? Well, I have to set the 2x plus pi equal to 0. And this will tell me my starting point. Okay, so this is starting point. So this would be, say again, negative pi over 2. If I subtract the pi over divided by 2. So that means I'm shifting to the left pi over 2. So what I'm going to show you is just, this is the way I would draw it. I know it doesn't seem right, but I'm going to draw the negative pi over 2. That is my center of my graph now. It's not 0, 0, it's negative pi over 2. And it's been shifted down to negative 3. So this spot right here is negative 3. So if I went up half and down half, this would be negative 3.5. And this would be, what, negative 2.5? If I went up and down half from there.
Wait, so the number in front of tan is not like your...
It's the amplitude still. It's still the amplitude. It's where you hit those first markers. It's where you hit the marker above the origin and below the origin.
Oh, so you're just halfway, but that's like all the further we're going.
Exactly. Yeah.
Okay,
I'm not going to
know.
draw like a bunch of hash
Okay,
marks and
yeah.
stuff. So it's centered at negative pi over 2 to the left. It's at negative 3 up and down. So I went up half and down half from there. I still have to go 2 hash marks this way and 2 hash marks this way. So again, negative pi over 2 is shifted to the left. So the 0, 0 is like over here somewhere. It's like over here, 0, 0, because I go over pi over 2 and then go up 3. 0, 0 is like up here somewhere. All right, so now the hash marks. This is going to be negative pi over 2, and I have to add my spacing. My spacing is pi over 8. That's my spacing. That's what we had to go find earlier. What is the spacing to that first marker when I go to the right? I have to add pi over 8. Because again, this was the spacing.
Wait.
There's my spacing.
I thought you had to find the spacing by doing 2x plus pi equals 0.
No, that's the starting point. Spacing is where you have to figure out the hash mark situation.
Oh, yeah.
All right. Now, I'm going to actually do the math here because I don't like writing negative pi over 2 plus 8, or pi over 8. I'm going to actually find common denominators here. I'll have to multiply that first one by 4. And so when I add these together, it looks like when I did that, it would have ended up being, this first hash mark would have ended up being negative 3 pi over 8. That's that first hash mark, that's that hash mark right there. Because I got common denominators, added the two together. That's how you add fractions, you have to get common denominators and add. I would do that off the side of my paper. I would add another pi over 8 going over, so this would be negative 2 pi over 8. Because I have to add another pi over 8 going to the right. If I subtract going this way, this is negative pi over 2, and I'm going to subtract pi over 8. So that'd be negative 4 pi over 8 and subtract another pi over 8, that'd be negative 5 pi over 8. So this spot is negative 5 pi over 8. That's going to the left. Then I subtract another one, and that's negative 6 pi over 8. It's getting messy. It's getting ugly.
I don't like writing up this graph.
I need to find a woman to
Yeah.
do to spooky stuff with.
Yes, so yeah, if you want to simplify that to be negative 3 pi over 4, that's fine. Yeah, so this is getting really ugly looking, just because I'm moving all these things around. I'm going to erase like what I just did there to find the spacing by subtracting.
Wait,
I'll just write down the answer.
After writing this.
Why did you start the negative pi over 2 in the middle again?
Because that's how far to the left I was shifting. That was my starting point. My starting point was negative pi over 2 to the left, and then it shifted down 3.
Yeah, I think they're just doing it on the outside, that's where you start. This one's tangent.
I know.
You start in the middle.
Like that,
8 and negative 2 pi over 8. All right. All right. Now, drawing tangent here, we have the asymptotes on the outside. So here's the asymptotes on the outside. The asymptotes on the outside. Tangent will be up here in the corner. It'll hit the first marker at its amplitude, hit 0, hit the next amplitude at its marker, and then go off to negative infinity. So it's going to look something like this. There we go. Just make those dots bigger so I can hit them. There we go. There you go. Again, this is not simple. It's like when you start shifting right, left, up, and down, it gets super messy. How do you label things?
Sloppy.
Yeah, it's just messy. Just because you have to get used to like where the amplitude markers are. You have to figure out what like where that pi over 2, like what does that thing mean in the middle? It means I was shifted. Like 0, 0 is up here. Like it's over here because I was shifted over pi over 2, negative pi over 2, and then I went down 3. So 0, 0 is like over here. The origin's over here somewhere. So I'm really far away from the origin.
That was our fourth problem, right?
No, that's their second. All right, let's do cotangent now. So let's do an easy cotangent, and let's go to a difficult one. Okay, now the good news is
It's pi over 2 or 2 pi again, right?
it's pi. So, all right, let's put some new numbers here. So let's go 5 cotangent 2x plus 7. Just gotta make up some new numbers. All right, so I consider this an easy cotangent problem. Cotangent, it still has the same frequency. Now normally we go over here to the right, it has 4 hash marks going this way. We're gonna still stick with that pattern. Now,
Graph's bigger, I can't write this.
so the idea with cotangent is that the full distance is still pi like tangent. That's the difference between cosine and sine. Cosine and sine go out to 2 pi, tangent and cotangent go out to pi. And now, for cotangent, it's just to the right. So what we have to do is figure out the spacing. We have to divide by the number in front of x.
My happy trailer.
So if I divide by the number in front of x, that is going to be my 4th hash marker down the road. Because we're not centered over the origin, so I don't have to split that in half again. So that's pi over 2. Then I cut in half again, and then multiply that one by 3.
So it's pi over 8.
3 pi over 8. Yeah. So there's your spacings. It's been shifted up 7, so this is 7 right here. That's 7, right above the 0, 0. And how far up and how far down am I going?
5.
5 from there. So I'm going to hit 12 and I'm going to hit 2 up and down. Okay, I'm going to stop here just for a second. Is there any questions?
No.
Morgan has a
We get
question.
this done,
Okay. What was the other question? Sorry, didn't hear it.
There's a Snyder one.
Oh, okay.
Just a,
All right. So now, asymptotes are just like tangent. They're going to be there's going to be asymptotes on the outside. Cool. There they are. Okay. Now, cotangent is almost a flip of tangent. It'll still go through the middle of your graph. It'll still hit origin in the middle. But instead of going upper right, it's going to be upper left. It'll hit the first marker at its amplitude, go through 0, hit the next marker at its amplitude, and then go up to negative infinity. So it's going to look like this. There it is.
I'll help.
Okay. There's cotangent. Upper left to lower right.
Cool.
Okay, let's do a difficult problem now.
Is that the last one?
Last of the cotangents, yes.
This is problem number 4.
Yep. Let's do the last of cotangent.
Or can I get a drink of water?
Can you wait till after this one's done? Sure, thanks. All right. All right. Okay, all right. Let's go with cotangent. 3x minus 5 plus 1. And let's say that's my function. I'm not even going to have a number out front. Okay, so this is a difficult problem, what I consider difficult. It's been shifted right and left, so we do have to worry about spacing. We do have to worry about the shift up and down. Amplitude's easy, amplitude's 1. So the waves are 1 up and 1 down from wherever your center's at. And then, and then we have to worry about spacing and starting point. So this is a cotangent. It's going to look like this. It's just not going to have the same starting point number here. These hash marks will be the parts we have to find. Remember, the spacing is normally pi. That's normal. But ours has been affected a little bit. So this is where I'm going to start this off to the front. I need to figure out the spacing first. I don't know why. I always figure out spacing. I need to know where the hash marks go. If I can figure out the hash marks, then I can worry about where the starting point is and figure out where they go from there. So spacing. Normally, on cotangent, we go out to pi. But on mine, I'm dividing by the 3 out front. So cotangent will go out to pi normally. We divide by 3, that's the number in front of x, right? And now I can figure out my spacing from there. We cut it in half, and we cut it in half again, and there is your spacing. This is the important number that I needed. It's the distance to that first marker. This is the space that I needed. Pi over 12. Now that I know the spacing is to pi over 12, right? That's from the first marker, or from the starting point to the first marker is pi over 12. I need to figure out where do we start. So I'm going to take the 3x minus 5 and set it equal to 0. That's going to figure out my starting point. Okay, so to figure out starting point, I'm going to add the 5 across, divide by 3, so it's 5/3. Okay, it's fine, fine and dandy. That's my starting point, so it's going to the right. So that means my graph is going to look something like this. This spot right here is 5 over 3 to the right. Now, how far up and down is it? 1. So it's up 1 and it's over 5. So really 0, 0 is over here if you think about it. It's been shifted up 1 and over 5 and 5/3. So it's over 1 and 2/3. So that's where I'm starting. And then I'm going to have 4 hash marks go this way, if that makes sense where 0, 0 is at. Does that make sense comparing it to where 0, 0 is?
Yeah.
So you can see it. Okay, how far up and down is the amplitude? 1. So this will be 0, this will be 2. The amplitude goes up and down 1 from there. So I figured out my amplitude, I figured out where the shifting was up and down, right and left, and now I just gotta figure out the spacing out to those markers. This is a part that's gonna get ugly, and I'm not even gonna make it look pretty. I'm just gonna leave it ugly because it's the easiest way to write it. So my starting point was 5/3, right? I need to add my spacing to it, to the right, to get to my hash mark. So I'm gonna add pi over 12. So this is 5 over 3.
So you're not gonna do the 20 over.
No, this is pi over 12. The reason I'm not even gonna get common denominators, the pi won't add with the 5 anyway. So I'm not even gonna worry about it. So I'm just gonna go, okay, there's that one. I'm gonna add another pi over 12. So now we're at 5 over 3 plus 2 pi over 12. Because that's adding the second one now. I'm gonna add the third one. This is 5 plus, or 5/3 plus 3 pi over 12. I'm not even like keeping this easy. I'm just adding the pi over 12 each time. I'm not even gonna try to simplify that. You can do this. I'm totally fine with you doing this. And then just adding another pi over 12. That's another 4 pi over 12. So it didn't work out nice and pretty. I'm not even gonna simplify. I'm not gonna get common denominators and even add those fractions together because I can't anyway. One has a pi and one doesn't. The asymptotes on the outside. There's my hash mark. Here's my other hash mark. They're on the outsides. Cotangent will go through the center. It'll be in the upper left corner, bottom right corner. So it'll look like this. There you go.
Wow.
Question?
May I use question, please?
Yes. All right. Now, tomorrow, what we're going to look at tomorrow is we're going to be going through problems where we're going to be doing cosecant and secant. We're also going to do a tangent cotangent problem. Maybe I'll only do one of those just to get whatever one you need. We will have another assignment tomorrow. I'll probably have a worksheet tomorrow. It'll be more than 5 problems on this one. Okay, because I'm going to mix tangent, cotangent, and secant and cosecant. So tomorrow might be a little bit longer. I'm thinking about 8, 4 problems, something like that. So 2 of each type. So tomorrow, expect that. It'll probably be a 2-sided worksheet. It'll be due later in the week, maybe like Thursday or something like that. We'll probably do another activity later this week where you do a little piece of paper and you have to turn it in, all that good stuff. I'm going to give you the rest of time today to work on your worksheet 1.5 part 2. That's on cosine.
All right,
Yeah,
I'll make
it on.
So I know I gotta take, so it's 2